Thank you, first of all, Suyash, for doing this with us.
No, it is my pleasure.
When I spoke to you, I thought it was really fascinating. The kind of work that you and the kind of journey that you went through as a mechanical engineer was really interesting. So I thought that the lessons that you might have learned over the course of that journey, you might actually be able to share a lot more with the people in India or working on different products that might benefit from your experience. So just to give everyone like a basic introduction about you, Suyash is an automotive industry expert with 10 years of experience and working with top OEMs around the world. He has in-depth knowledge of electric vehicles development, currently focused on digital transformation, data-driven development, and cognitive engineering practices. He has a strong academic background and he's done his MTech from IIT Bombay and MSc from Cranfield University. So that's a bit about you, just so that everybody knows what we do. So I obviously am Anishay, and we run a company called Exclusive Magnesium. We deal with magnesium alloy development, and we essentially, throughout the course of our experience, we found that most of the engineers and the mechanical engineers that we work with love to understand how the best products in the world are built and what goes behind that. So I thought having this conversation with you might help some of them do a few things differently, maybe, and
Yeah,
that's the whole objective.
absolutely.
Yeah,
Yeah, thanks for the introduction. I just want to add one more thing.
yeah.
It's not just for engineers in India, but around the world, as this is a common engineering problem around the world. So, yeah, it will be helpful for everyone, I hope.
So let's start off with your journey itself. You're an engineer. So just take us through your journey, how you started from IIT Bombay, and then eventually you did your MSc, and then you did IIT Bombay MTech, right?
Yes, so both my bachelor's and master's were in mechanical. I have always been fascinated about how machines work, uh, how different parts come together and perform so seamlessly. Uh, so that's why I chose mechanical engineering, which I pursued till now, uh, and had quite an interesting experience throughout. Uh, my project in IIT Bombay was about uh, performance estimations of gas turbine engines. Uh, then I moved in automotive field, where I started my journey in engine design, which was again slightly related to my education, but obviously it's a wealth of knowledge. It's a very complicated machine where uh, the temperatures are quite high, and at some parts of the system, the pressures are quite high as well. So it is pretty critical to design these systems in a safe and reliable manner. So that was the base on which I started my journey. Then I moved on to system engineering and vehicle efficiency. That is my core expertise right now, where you have to understand how different aspects of the different components of a system and subsystems affect the overall efficiency of a product. So that's what I have my current expertise in. Uh, So yeah, that is a little bit about my journey so far.
So you've worked on different kinds of vehicles as well, right? So I think you also had a little experience in motorsport, and now I'm assuming it's more commercial.
Yes. So motorsport is an interesting field because we push the envelopes of engineering in all aspects because we want to get the best performance out of a machine. So that's where it's a little bit like extreme engineering, where uh, you do quite detailed analysis and try to save weight, try to increase performance in every little aspect that you can. Uh, so that was my journey in motorsport. But currently, I'm working on trucks, and trucks have a pretty different perspective. So a truck is like a cost center, uh, and they are not driven for pleasure. They are driven for uh, business, basically, to earn money, to provide services, and to add value to the whole logistics sector. So it has slightly different requirements as far as systems are concerned. So yeah, it's quite an interesting way to look at a vehicle, uh, a ground vehicle, from different perspectives. And that's what I wanted to achieve by taking different experiences.
So when you're going about the design process, obviously they're very different. Where do you start? Where do you start with the whole thing?
So again, it depends on what uh, uh, you are designing. Uh, our focus for today's talk is obviously weight, because it, I have worked on vehicles which move, and the efficiency is then depend on how much weight you have to move. So anything that is mobile, you need to you have weight aspect sort of woven into the whole system design. If that vehicle has to fly, then it is whole another level of weight optimization. As we can see in airline industries, it is absolutely critical to save weights on each and every component. So there is a weight audit on even nuts and bolts. So interestingly enough, I started working on bolts. So right after my MTech in IIT Bombay, I joined engines department, and the first project that I got was to develop design process for bolts that are used in the engine. And not to mention, my friends were mocking me. They were making fun of it, that, oh, you're a engineer from IIT and then you're working on bolts. So it seems like a very insignificant component. But as it turns out, the bolts in current IC engines are pretty high tech. So we turn them till they yield inside. Uh, and this was because we could save a lot of weight. Uh, so by optimizing the design of bolts, we could save some weight on the engines. So that is why the design was so advanced for the engine head bolts. And so basically, that is, you can understand the importance of weight saving, where even a ground vehicle where which weighs at least a ton, right, in most cases, uh, we were striving to save a few hundred grams in bolts, uh, because that's what engineers do, right? That's what you as a designer have a responsibility to build your system in a way that is more efficient to run. Uh, so there are obviously, when it comes to designing, there are multiple aspects, and the one aspect that I worked on that time was design optimization, and there can be different goals for optimization. And my goal at that time for that project was weight, to see how can we save weight by optimizing the design of bolts.
Like saving a few hundred grams seems like a very aggressive strategy for weight saving. How does it impact the overall vehicle? Like doing this weight saving exercises for obviously not just bolts, but I'm assuming for every component. How does this impact like
Yes,
an overall vehicle?
correct. It's a good question because it may seem little excessive or over engineering, saving a few hundred grams on a diesel engine, which weighs a lot actually. But if you consider a car as a system, it has about 20,000 components, right? Uh, if you don't optimize weight, your car will end up quite heavier than your other competitors. So that this is why, uh, even though the small saving that you get in small components, it seems very small in the overall weight of the system, but it is important to do that optimization on each and every component, because when they add up, then it will create a bigger difference on the system level.
Were there any common strategies that you would employ to achieve this kind of weight saving or lightweighting or optimization?
Yes. So first strategy as a designer is weight optimization. The design optimization. So the problem is with that is, now with like we have spent so many years designing these machines, right? And we have optimized their shape as much as we can, uh, as much as we could so far. So there is not much room into it. So unless you come up with smart materials, uh, there are many types of smart materials, and or you change the material itself. So if not composite, then you have to go with lightweight materials. Uh, and what then what needs to happen is, you are going to re-engineer that component, right? Because once you change the material will have different properties, and you will have to re-engineer the entire component again. Uh, but that is the only avenue that is available in most cases these days, because you're done with the shape optimization of that component after so many iterations of design, that now you can look into different materials to save weight. And one more point I want to add is that uh, you can do that strategically. So you can identify components which where which are critical, and where you can save the most amount of weight, right? So there are many components in a system where they are over designed, like they don't need that much strength or stiffness for the given function. And then you can replace those components, some material, with some lightweight materials. So you have to identify smartly which components you can replace with lightweight materials.
Are there any materials that you have come across that are emerging in the automotive or any other sectors that you've seen in your networks?
Yes. So we have seen increased use of plastics, different types of plastics. So earlier they were only used in interiors. Now we have started replacing a lot of components like a dipstick in an engine, right? which was metal wire earlier. Now we have replaced it with glass fiber to save some weight there. Because we have these materials readily available. Again, it doesn't matter how small weight you are saving. No matter how small weight you're saving, it matters that the materials that are there, uh, that are available to use, you look at those options and you implement those material changes.
Have you come
Yes.
across magnesium anywhere in your experience working with motorsport or anywhere else?
Yes, more so in motorsport. Motorsport is an industry which is continuously looking for these alternative materials where they can save weight. As I said, we are always pushing the envelope of engineering to come up with uh, new materials, new designs where we can save weight and improve performance of our car. So initially it was aluminum, which was very popular. Obviously, it came straight from uh, aerospace, where aluminum was used. Then uh, carbon fiber is there, where we can produce strong components with very lightweight design. Uh, Magnesium, to be honest, as per my knowledge, obviously you are more knowledgeable in that, but it has emerged as a very it has emerged as uh, some a material that is in between aluminum and carbon fiber, where uh,
Absolutely. True.
yeah, for some components, if you don't want to, because carbon fiber components, if you know the process of manufacturing carbon fiber components, it is very labor intensive. So you have to cut the layers of carbon fiber and lay them manually. In fact, as a part of our course in Cranfield, we have done that. We have manually created the carbon fiber components. Uh, so that is not very economical. Whereas magnesium is still a metal, you can cast it and you can create some high precision components with it. You can treat it just like, yeah, so the manufacturing process remains same as aluminum. You are not creating something completely out of the box like carbon fiber. So I think magnesium has a lot of potential to uh, replace aluminum where you want to save more and more weight, and replace carbon fiber where you want to automate the process of manufacturing. You don't want very high cost components which are built manually. So magnesium is actually very well placed to replace both of these materials, which I think we will see more and more in the new designs to come.
So I'm sure there's a huge decision when it comes to, especially in sectors like automotive, when you're trying to improve the design. There's also like a huge cost element involved with the whole thing. How do you balance that? Like I'm sure every decision you make has a cost implication. So
Yes,
how do you weigh that as a criteria?
absolutely. Yeah. So you have raised a valid point that cost is obviously a very big constraint on what we can implement in our designs and what we cannot. Uh, because, and again, it depends on what type of product you have. So if it is a material intensive product where you are going to use a lot of material uh, for a then for example, take a car, right? You use so many materials and the weight is also really high, so many components. So the cost of components constitute the majority of the price of the car. Whereas there are some systems where uh, it's not material intensive. where you can use slightly costlier materials to improve the performance of the system. Uh, Even in automotive, you can replace, for example, some of high-end vehicles. They can implement these alternative materials to, uh, uh, as I said again, strategically, that you have to choose the candidates where you want to replace these materials. But you can certainly do it with a little cost impact. But what is important is that you are delivering value to the customer. So the customer will be willing to pay more if you are delivering that value. So if you replace a critical component and save some weight, then you are going to get uh, more kilometers out of 1 liter of petrol. Uh, that is going to bring down the fuel consumption. That is direct value towards your customer. Uh, so if you are uh, if you are delivering value which is worth it, then the customers will be able to pay. Also, in a competitive arena, you can sometimes use these kind of materials to offset some of the other deficiencies in your product. For example, if you build SUVs, right, and you have a problem with high fuel consumption, uh, more than your competitors, then probably you have to identify these areas where you can save weight and go a little aggressive about it to be competitive at the first place. Because if you're not competitive, you're not going to do a good business in the market. So these are the two strong reasons where if you are creating value and if you are creating competitive products, then obviously it is worth spending a little bit more on these alternative materials.
Okay. So I'm obsessed with frameworks and tools. For example, like lean manufacturing is a tool that you would use to do efficient manufacturing, right? In the same way, product design has its own versions of that. Is there anything for mechanical engineering or hardware design that you have followed? And
Yes.
there's
Yeah,
all
yeah.
these
There are many
things, right?
frameworks,
But,
and there are many changes in that as well. So we were increasingly using waterfall methods, waterfall frameworks till now, but now it is moving towards agile, and so we are adopting some good practices from IT industry and so on, because now the companies are also becoming more and more digitized, and teams are working in a way that is not very traditional. So there are different frameworks that we are, and our industry is constantly evolving. So, for example, Agile, I did not know much about it, but now I have to learn it because that's what we have implemented in our current company. So it is, as an industry, we are continuously evolving with these frameworks. But what remains constant is your commitment to processes. So just like in manufacturing, we also have to have strong processes and follow them to provide good quality work, right? It is not necessary that our output is something physical, but even if we create like an analysis report, it has a quality aspect to it. So as long as we are following processes correctly, then we can produce good quality work. Tools are there just to sort of help this process. Once you're clear about your process, then you can choose the tools accordingly, the right tools accordingly. But yeah, everyone should concentrate on processes and developing these strong processes where, for example, if there is a testing process for a product, then what you need to do is develop a strong procedure for that testing, and identify all the phases in the testing and identify what are your requirements in those phases. Once you have identified those, then it becomes easier to choose the right tool for every phase. So if it is process based, then you can choose the tools accordingly and write tools which will actually help in your productivity. So rather than, yeah, don't focus on the tools much, but focus on the processes and then choose the tools accordingly.
What are the upcoming innovations in your sector that you would say the world should be excited about?
Uh, so we are living in a very exciting time, to be honest. It's a great time to be an engineer. Uh, no matter where you are in the world, you have opportunities all around the world, right? I have worked in the UK before, then back in India, then now I'm working in Sweden. That is because if you are skilled, then everybody around the world would like to work with you. Uh, Also, it is very important to uh, keep abreast with these upcoming trends, and this is one of the reason why I uh, work for different companies in different countries where they might have subtle changes in culture and in new trends and how advanced you have the industry is there in that particular country. So one of the trend is obviously what I mentioned in you also mentioned in my introduction is my current focus is digital transformation, how we can use data to find decisions. Not just earlier it was used for business to some extent, but now we are talking about data driven product development, where how we can make strong decisions in product development based on the data. We are not we don't want to be in the dark anymore. We want to know how customers are exactly using our product, what are their requirements, and so that we can uh, efficiently produce the right product for the right market. So that is the new, uh, what I would say, a paradigm where you have to
Right.
move on from previous processes to new process to understand your customers better.
Yeah, I feel like data and product development is a double-edged sword, right? So always product designers would love to have more data, but at some degree, there is a bit of leap of faith when it comes to development. Do you feel
Yes.
that, or nowadays is that also eliminated?
No, there is leap of faith. There is engineering judgment used at lot of places where we don't know exactly how this product is going to be used, right? Maybe it is some senior manager who has worked many years and who has addressed addressed many customer complaints and so on. Uh, but that is again, it comes from personal experience, so it is anecdotal uh, data. Uh, it's not a strong customer usage data, right? What we want to know is what is the usage pattern. For example, if we take, let's say, there is a huge market in London and many other European countries where there is a market for foldable bikes, right? A
Right.
bicycle that you can fold, because you cannot take your full bicycle on buses or trams or subways. Uh, so you have to, but you can take a foldable bicycle, right? Now, what earlier people used to do is, okay, how can we fold it as compact as possible? That was their focus. But uh, now what they have come up with is, okay, how much? So again, coming back to this point where uh, you might think that customer wants something else, but the actual requirement is different. So now we are seeing a trend where these foldable bikes, uh, uh, they have shifted from uh, compacting it to a certain size to designing it to a certain weight, because
Okay.
they have realized that the users have to carry these bikes, right, when they are not riding it. So now we are seeing a lot of bike companies who sell these bikes. They are showing they are showcasing, in fact, the weight of their bicycle, because now that has become important. And if your cycle is below 10 kgs, then obviously it is a very good factor to buy that bike, because now because it is lightweight to carry it around, right?
Yeah.
So that is something that we are seeing, where it was just an engineering judgment of one designer, or what we think, that there was a gap between what a designer thinks and what customer wants. But then slowly industry evolves to close these gaps, and these digital transformations and data analysis, they can help you in closing these gaps pretty fast.
In terms of resources that you usually go to, these could be like, say, maybe blogs or podcasts, or maybe even books that you might be reading. Are there any recommendations, something that
uh
you or
yeah,
you like?
that is again a very this is one of the reasons why it is again great to live in this era, because uh, earlier you only had limited knowledge resources. Now you literally have infinite knowledge resources, right? Now the content, there is so much content out there that you can't even go through all of it, even the free stuff, right? When we
Mm.
were in the IITs, we used to watch lectures from MIT for free. But then we quickly realized that there is like so much content that you can't really go through it all, right? You take any subject, if you want to learn about it, there are like many YouTube videos, many courses from around the world. So yeah, now we are living in an age where data has the information has exploded, right? And so I just want to point out that you have to uh, you have to plan your study first, because you can't just chase any information that you are getting. Uh, this is why it is important to know what you want to know, uh, and then go accordingly. So, uh, f- for example, like online, look for some. I definitely depend on a lot of videos and courses online. Most of them are free, but it is worth spending some money as well if you want to get certified or something. Or if there is a structured course that is going to teach you a particular subject in a very pre-planned and structured manner, then it is probably worth paying some money as well for these courses. So I'm a very visual learner. You have to understand what kind of learner you are. If you enjoy reading more, then there are numerous books out there then that you can choose from. But if you can listen to podcasts as well, many podcasts. If you are addicted to, I mean, this is why it is great to live in this era, is that if you're addicted to social media, for example, then you can follow certain pages where uh, they give you these little bits of information in on the social media itself. So it depends on what kind of learner you are, right? For example, if you want to learn German, there are now many Instagram pages where they post about few words, few German words that you can just glance while going through your feed on Instagram. So that I found that that is a really great way to learn. We used to have these flashcards before. Now
Yeah.
we can have small bits of learning in entertainment. So, but yeah, it is important that to first analyze what kind of a learner you are and what you enjoy the most, and content is there in everywhere. So you just have to see these avenues where you can get this content and then go accordingly.
Actually, this is something that I've been wondering about the electric vehicle space myself.
Hmm.
There's so much battery development happening, advancement in battery happening simultaneously, and there's also lightweight materials entering the market constantly, right? So,
Yeah.
where do you feel like the jump would be? Would it be the major improvement has to have happened through the battery, or both are equally as important?
Both are equally important. Um so if we look at the history of, in general, portable devices, right? Why someone's sometime created a laptop where they put a battery on a computer, and those laptops were actually quite heavy that time. But uh, I mean, industry quickly picked up uh, that concept, and now if you see, hardly anyone buys desktop, right? So everything has become portable. So that is just one of the examples to show how these portable devices are evolving. Earlier we used to use these kind of headphones, right? Now then there were Bluetooth headphones where still 2 years were connected by a wire. Now uh, we have quickly gone into an era of truly wireless headphones. So that is just a trend where how devices are becoming more and more portable, and that's what people are liking as well. So that's where the market is heading. But one of the big drawbacks of batteries is that it adds weight. Batteries are not, you can handle any battery, you will feel that it is much heavier than any other components, right? Uh, right now, what uh, research going on in battery field is about the chemistries. Uh, so how we can store more and more charge in the same size batteries. That's what they are researching on, so that we can have more charge for a given weight in that system. But you can also solve this problem by uh, reducing weight of other components, right? Uh, so you can achieve the same goal uh, by two different means. Uh, Obviously, chemistry research will take many years. It's not something that you would uh, quickly come up with, right? So until then, you need to find other solutions. So the other solution is, obviously, you can reduce the weight of other components in order to have more and more battery capacity installed in your device. For example, if we take, now electric scooters are becoming much more popular in India, right? Uh, there is battery research going on that how can we have, so this is called battery power density, how much, and energy density. So these are the two terms in batteries where they say, okay, how much energy can the battery store per kg, right? Uh, so when we when the battery research goes on, it is to increase this energy density and power density of a battery. But if you reduce the weight of other components, then even without one thing is to increase the battery density, energy density, so that you can pack more energy for a given weight. But until we get there, we need to also start looking into reducing weight of other components, because that is as equivalent and as important as increasing the energy density of the battery. Because ultimately it is what your machines or devices weight is the final weight is going to be important. So if you can reduce weight of other components, you can install more battery capacity with the same energy density. So you can increase battery capacity just by reducing weights of other components. So this is how this play is now going on in the industry. Uh, the both research streams will continue,
Right.
right? We are going to continue researching new chemistries or new packaging method of batteries where we can store more and more energy for a given weight. But I think there is a blind eye right now on reducing weight of other components, which I think will pick up. Some companies are doing excellent in this field, uh, whereas other companies are lagging. Each company has to decide for itself how they are, whether they are leading in that particular area or lagging than the industry.
The short term, it has to be through mechanical optimization, and in the long term, probably chemistry will come in as a big player in this segment. I'm
Correct.
assuming in the whole portable sector, not just in electric, right?
Yes. So wherever there are batteries involved, I think you will have this issue with weight and packing more and more battery capacity.
Where can people follow you? I'm sure people would love to follow you, see what you're reading, see what you're doing. Where can people do that best?
So I'm active mostly on LinkedIn. We can probably give them a link to my profile. I try to share as much interesting material as possible on LinkedIn. So do follow me. And if you have any ideas to share or just want to connect with me for any future projects, just send me a connection and I would be happy to connect with you on LinkedIn.
Awesome, man. This was a great conversation. Thank you so much, Suyash, again for doing this. You're a great sport for doing something like this. I'm sure I got so many insights, so many great bits that I would love to share. So thank you again, and
Yeah.
hopefully,
Thanks for the nice words.
yeah, hopefully sometime in the future, if I do have any engineering challenge, I will reach out to you. That's
For
something
sure.
that,
Yes.
yeah.
Yeah, I enjoyed the talk.